Series combination. Series combination. What is the meaning of series combination? In the series combination, we have the capacitor connected in series, and this will be connected to a battery. This is your Q. This is your Q. This this will be your capacitor 1, this will be your capacitor 2, and here you have a battery. That battery is providing you the potential difference. Now always remember, in series combination your charge will be same, and your potential difference will be different. I repeat, charge is same, potential difference is different. Charge is same, potential difference is different. That means your q1 and q2 and q will be same, but your potential difference will be different. That means your total will be equal to v1 plus v2. Do we have any other information? Yes, we have another information. We have quick climbing valley. That means q is equal to cv. That means v is equal to q over c. That means in place of v I can write q over c. This will be equal to q over c1 plus this will be equal to q over c2. Q is constant, you can cut q. That means what? That means your 1 over c will be equal to 1 over c1 plus 1 over c2. This is the series combination. What about parallel combination? In parallel combination, you will use, parallel. Parallel combination, you will use two capacitors parallelly. Okay, this is your capacitor of charge C1, this is of charge C2, and this is connected to external voltage. This is connected to external voltage. Here current is flowing, current I is flowing, connected to external voltage. Here just remember, charge is different, and what is same? Same is voltage. Charge different, that means q is equal to q1 plus q2, and voltage is same, that means v is equal to v1 equals v2. We have formula, yes, we have formula, quick climbing valley, because of which we can write quick climbing valley. So what in this case you will get? In this case, if you substitute in place of q, cv, charge is different, this is 1, this is 2, but voltage are same, this is 1, this is 2, this will get cancelled, and you will get c is equal to c1 plus c2. We'll get c1 plus c2. So this is the difference in the series combination and parallel combination. In series, it will be reciprocal. In parallel, it will get add on. Okay, now let's see some numerical based on this. Yes, when three, I've explained the concept. Now you will going to answer me the this thing. When three capacitor are connected in series, the equivalent capacitance is equal to what? Three are connected in series. Remember, three are connected in series. Three are connected in series. The equivalent capacitance is equal to, we have 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. Answer A. Okay, then what we have? We have second question number two. Question number two is, when three capacitors connected in series, the capacitance is equal to, same question. This will be the formula B. In this case, if there will be a dot 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 dot, but see the last one, this is C3. C3 is what? The answer will be what? The answer will be B. Okay, then next one. If we have the capacitor, the equivalent capacitance is greater than bigger individual capacitance of the combination. Yes, it is asked that in which combination there will be a greater capacitance. You say series, parallel, both, or none of this. In series, what happen? It will divide. It will divide, na? In series, it is dividing. But in parallel, what is happening? In parallel, capacitance is adding. So see, in series, it will get divided. But in parallel, what will happen? Your C will be equal to C1 plus C2. That means what? In this case, there will be the add up. That means your capacitance in parallel will give the greater uh, capacitance value. Okay, then fourth one. Which capacitor combination will hold the least amount of charge? Yes, if parallel have the maximum, then series will have the least amount of charge. So the option will be what? The option will be A, series sequence. Okay, then yes, parallel plate capacitor, the same guy. I told you now I'll going to ask this question here. When more capacitor are connected in parallel, what happened to the effective capacitance? Now I am damn sure that you will be able to answer the question. Say, tell me, it will increase or decrease? Yes, it will decrease. In series, it will, yeah. In parallel, it will, not decrease. It will parallel, it will increase. Option A. Okay, then